Our final problem is going to kind of talk about which points on the graph are closest to a fixed point. So it says which points on the graph y equals x squared plus 5 are closest to this point 0, negative 2. So let's just draw this situation. I'm just going to sketch it up here. X squared plus 5 looks like this. This is that graph. And the point 0, negative 2 is down here. Okay? So if I want to think about the distance for all these points, there are lots of points on this graph. I want to see if all these points, which one is the closest to that fixed point. Okay? Now this is kind of a simplistic version. You can have much more difficult graphs, harder points on maybe the x-axis, but just for this to start, I think this is fine. So we want to figure out which of these distances is going to be the shortest, okay? Because we want to be closest. So in this case, we'd be looking for a smallest value because it can get as big as you want because points are going to keep going on this parabola. So the way we do it is we're going to use our distance formula. Now, if you recall the distance formula, x1 minus x2, y1 minus y2 squared, and these were for just two generic points. So let's say we have x1, y1, x2, y2. Those are just two generic points. So I'm going to call my generic point xy, x1, y1, and I'm going to call this point x2, y2, just for general sake. So maybe I call this generic point here, and then this is my y2, and I want to find that distance. But because this point is just x and y, it literally can represent any point on the parabola. So d is going to equal the square root of x minus 0 squared, because I take the x here and the x here and subtract them and square them. And then I'll take y minus a negative 2 squared. And I'll clean this up. So this would simply be the square root of x squared plus y plus 2 squared. So this is the distance between any point xy and this point 0, negative 2. The problem with this is this still has three variables. It has d, x, and y. And that'll be true of a lot of these. We'll have to do something to get rid of them. In this case, we're going to substitute. So the nice thing is I have x. I would like to get rid of x. But remember, for all points on this parabola, y equals x squared plus 5. So I can substitute that into this equation. So my distance function in terms of x will simply be x squared plus x squared plus 5 plus 2 squared. So that will give me a distance of x squared plus x squared plus 7 squared. Now for now, I'm not going to worry about this. I'm not going to simplify it. This is fine. But these are going to be the distance from 0, negative 2 to any point with a given x value on that parabola.